So this time we have a fairly simple equation here that we're trying to solve for theta, but it does involve a secant, and we're going to use a calculator, and then that kind of makes things a little bit tricky. Okay, because you don't have a secant button on your calculator. Okay, and then we're going to be doing our answer in radians. All right, so I'm going to try to give you a visual of all this and how this is going to work. So first of all, I'm going to change it from secant to cosine. So 1 over cosine theta is equal to -4, okay? And then through your magic of algebra, you're going to get something like cosine theta equals -1 over 4, okay? So now we know so now that at least looks better. It doesn't have the secant in there anymore. So we know we're going to go to a calculator. We know we're going to use an inverse cosine function. So inverse cosine of -1/4. And then what is that going to tell us? Well, I'll just draw it right here. So if you think about what that means, inverse cosine is either first or second quadrants, but it's not positive, so it's not going to be in the first quadrant, so it's got to be in the second quadrant, okay? So we get our calculator out, we type in inverse cosine of -1 divided by 4, and we get, this is approximately equal to, and this is a good answer, 1.8235. It rounds up. Okay, so that's great. Now where is 1.8? If you remember, pi over 2 was approximately 1.57. So it's over here in the second quadrant, which that's what we were expecting. Okay. So there's our angle. We know that one. Great. The problem is, though, there's another angle that has a negative cosine. Okay. So where is that? Well, it's over here in the third quadrant. Okay. Now the reference angle here and the reference angle here have to be the same. But what is that reference angle? Okay, so you would take pi and subtract 1.8235. Okay, that will give you this reference angle right here. So I'm going to do that on my calculator. Pi minus 1.8235. And I get 1.318 Okay, that's what I got. So that's the reference angle. So how do I get this angle that's going from here to here? I have to take pi and add that reference angle. Okay. So, and you might think that that's weird. I'll talk about that in a minute. And I get 4.45. Looks like it's rounding up. They probably put 9.6. They put 9.7. Oh yeah, because we're going 4 decimal places. Yeah, so 4.4597. That's this angle right here. You could check and make sure it's in the third quadrant. That's what you're expecting. Now, it seems a little odd because it seems like, oh, I subtracted pi, I added pi, but that's not what really happened. We were finding the reference angle here. Oops. We're finding the reference angle. And we need that reference angle to find the real angle we're looking for in the third quadrant. Okay? So you might have to watch this part of the video a couple times because it might seem a little confusing to you. All right. Now it says to give our answer in radians. We're going to give all the answers because they didn't restrict us to one time around the circle or a particular interval. So our first answer was right here, 1.8235. And this is what theta is equaling approximately, plus or minus 2k pi. And then also theta equals approximately 4.4597 plus or minus 2k pi. And so those would be all the solutions. They are approximations, but that's what we have to do because we have to use a calculator to find these. Okay, so hopefully that makes sense. Like I said, you might have to watch this video a couple times. Okay. I don't know why it's recording still. Well, now I know why it's recording because I wrote it down wrong. That's supposed to be 4.459. You're probably wondering, why did she put a 3 there? It's supposed to be a 7. Okay, there, that looks better.